Hello, this is Lucas Doyle with a demo of Stoolbotics, the robot simulator that I wrote. Um, as you can see, there's this command window over here, and this is where you enter all your commands. So you can get a listing of all the available commands by just typing help, and then the name of any command will display help for that command. So with this axis command, I can turn the axes for the robot on and off. So most aspects of the simulator are controllable in this manner. So if I type floor, I can turn the floor on and off, and so on and so forth. Now, simulator, not very useful unless it can simulate anything, so let's start doing that. And that's the play command. But as you'll see, nothing's moving. And that is because none of these joints for this robot are set to anything. So if I look at robot.q1, this is the first joint for the robot. It's set to be 0. So let's make that actually be something. So we'll set q1 to be 0.1t, which will just rotate that first joint by a constant factor. So trace kind of screwed up here, so you can fix that with trace clear. And yeah, so you can see this isn't very exciting, but it's just rotating that first joint by a constant factor. You can use more advanced equations too. Trig works. So you can oscillate things. If we do q2 as 0.1 times sine t, we'll see it draw a circle. So, most parts of the simulator, you can play around with this all day, like, 0.1 t. So that'll just loop around there. Let's see, what else? So the time scale for this thing. So all the simulation is dynamic, so you can control how fast and how slow it simulates. So if we set the time scale to be something faster, well, first let's see what it is. So it's 0.02. So if we set the time scale to be, let's say 0.5, then we start simulating things faster. Similarly, if we set it to a negative number, we'll go backwards in time. So that's how that works. The set command works for pretty much anything in the simulator. So if we want to set L2 to be something bigger, set L2 to be 500. So now that second link is really long now. I'm trying to think what else. If I stop the simulation, I can record movements. So let's just do something, record something, and I will play now. So all of these movements are now being saved to a file. So just to prove that to you, we'll set the time scale to something positive and stop. So now if we play something CSV, it'll play back the movements that we just did. And one of the useful parts is because this uses just a simple comma-separated variable, you can very easily write something in another language, MATLAB let's say, to output joint angles for this thing to move at, and that you could do inverse kinematics that way. There's a lot of flexibility built in by default. So I think that's about it. Oh, I guess one more thing. You can look at a bunch of other robots here. These are all just simple specified in JSON files in the robot directory. So if I load sample here, we get a completely different robot. And you know, this robot has it's a little crazy, but it has a prismatic joint that's just displacing along an axis as opposed to rotating around one. There's a bunch of them in here. So it's snake. So this is it's got a bunch of redundant degrees of freedom in it. So, you know, there's a lot to play around here, a lot to teach beginners some fundamental concepts in robotics. And so I hope you enjoy. Thank you.